On this episode of the show, I have with me Sumit Arora. He is VP of Advanced Technology at Ascend Learning, and we're going to be talking about, experimentation and productionizing AI, and we're going to be talking about moving from prototype to production and why it's harder than it looks. A little bit about designing new user experiences for AI systems, and we're going to be talking about the role and relationship with the product team, identifying value, especially in new and advanced technologies, and maybe a few other things in there as well. Sumit, thanks for taking the time.
Thank you, Amir, for having me today. I'm looking forward to sharing my experiences and knowledge with your audience on the tech track today.
Absolutely. And before we start, can you tell us a little bit about what Ascend Learning does?
Yeah, so we are a healthcare-focused education technology company. We play mostly in the vocational education and certification space. So if you think about our biggest business unit, which is ATI, we help almost 60 to 70% of the nurses in the US pass their NCLEX exam. We are the leading provider of software, content, and data to nursing schools, and that helps them train their nursing students. Similarly, we have other categories and business units that play in allied health and education and certification.
Very cool. Very cool. Okay, so this episode, we're going to be talking a little bit about, and I love your title, Advanced Technology, because I think that's how I refer to a lot of this stuff as advanced technologies. And I guess question one, just to kind of kick off, when we think about just advanced technologies and we think about the challenges around going to the stakeholders and understanding the business problem and trying to figure out whether or not this new shiny thing is something we should attempt to use for their problem or not use for their problem. When you look at the business problem, you look at your stakeholders, and you look at the tools available, how do you sometimes balance the new thing and it's always promised to deliver a better result, a better future, a better solution? How do you balance not just gravitating towards something like that?
Yeah, it's a great question. Actually, when we think about AI nowadays, everybody has a million ideas. So I get bombarded by at least 100 ideas every day, not exaggerating, from inside and outside the company, from my personal life, can AI do this? Can AI do that? And in most of the cases, we can build the prototypes for solving these business problems and product problems pretty easily, right? It's very easy to get an LLM to answer one question well, but it's extremely difficult to get the same LLM answer multiple questions, million questions reliably over and over again, right? So that's where the challenge is, scaling from a simple prototype to a production quality system that is secure, that can scale to the demands of end users, that's also highly available. So all those things come into play when we talk about productionization. It should be highly available. It should be secure. It should have low latency. The accuracy and the consistency with which it is providing answers or, taking decisions should be close to 100%. At least that's what the expectations we have from production AI systems. And that's where it's very easy to build prototypes, but it's very hard to scale them to production quality. And it takes different skills. And, fortunately, I've been working in this space for quite some time. So I have some idea on what kind of skills it takes, what kind of engineers and expertise we need to take something from a prototype to production.
Absolutely. And maybe, that's a question I definitely want to get to. And maybe the question before, when you look at, I guess, and we can use AI as the advanced technology. So we have a good firm example. If we're looking at AI and you kind of mapped out going from prototype to production, some of the things that have to happen. If you were to map out any other technology that you're going to develop in the last 20 years, you've done plenty. If you were to take one of those and superimpose what has to happen to go from prototype to production, how different or where are the differences from an AI solution versus the other solutions you've delivered in terms of that prototype to production gap? And the reason I ask is everything you said sounded like, well, those are things that every system has to kind of go through.
Well, that's true. And the difference lies, maybe I'll take an example of data, right? So I was fortunate to be part of the data revolution as well, the big data, so-called big data revolution. And when the Hadoops and the Sparks of the world were getting invented back in 2009 and 2010, there was innovation happening in that space and people were building prototypes. And as they started deploying those prototypes to production, we ran into similar challenges, consistency, high availability, and these prototypes, real time, all these prototypes that were built on, let's say, I wouldn't say lower amounts of data, but not ready for production, right? They were able to run, with the help of engineers, we were able to actually build large scale distributed systems producing data, processing data. But then, how do you scale processes, which, how do you scale your, say, for example, your workforce, which is more, which has more expertise in SQL, right? So that's when we realized, oh yeah, we have to probably make it user friendly, developer friendly, and we have to make sure that the queries respond in time. So, other frameworks and companies evolved, but the pace at which that was happening was still manageable, right? What's different with AI is the amount of innovation that is happening in this space. So you read about something, you build a prototype, and you deploy it to production, and it's by the time you go to production, it's already outdated, right? So it's very hard to actually keep pace with the innovation, the technical innovation, as well as the use cases that are coming up. And another differentiator here is there is not a template, right? So if you think about, even if we are building data systems, there was a template from internet, there was a template from software engineering that, maybe our product people and business people can copy to actually come up with the requirements. It was deterministic software in the sense you exactly know what you are looking for, which is not the case here with Gen AI, right? There is not like a template to follow or something that we can take inspiration from other industries. There are a few coming up here, but still it's very, very new, right? So that's one challenge, the pace at which it is happening. And then it's non-deterministic, right? How do you test the output, right, that a Gen AI system or a large language model produces? So those are some of the challenges, and that's where we need a mix of skill sets to build systems like that. And that's where I think the difference is from other technologies. And not only that, it impacts everything, right? So data was very focused on data systems, but AI is everywhere.
Absolutely. I love the way you walk through that. And you touched on this, and maybe this is somewhere to go as a follow-up. You mentioned skills, and obviously data teams, data roles, data departments have been around a lot of companies, right? Your title has changed to advanced technology. I said I really like that because that's how I refer to AI and some of what we're seeing, because it's not just data. It's gotten beyond what data was maybe 15, 20 years ago. Even with just data scientists, it's gotten more technical. I guess when you look at the type of skills, the type of abilities you need to deliver, and maybe not even down to the individual level. We can maybe talk about this a lot higher level at an organization, because I'm sure a lot of orgs that have some data people think, okay, well, we can maybe do something around AI, but the gap to what the talent they might need or the strategy is going to be different. Talk to us a little bit about that.
Yeah, that's a great question. It's something I've been grappling with in my life and my work life as well, on what's that right skill set to build these AI systems, right? So, and what I have concluded, at least so far, and it can change tomorrow because given the pace of AI, but is that you need people who have experience building distributed systems, right? That's one of the skill sets. So think about people who know how to build event driven architectures, how to manage and build APIs that scale. How do you optimize memory usage? How do you handle large concurrent users? How do you build systems that are fault tolerant, right? And how do they process the systems that process large amounts of data? So that's one aspect of it. I call it like distributed system expertise. And then you also need those people to know a little bit about, how model works, right? How do you tune the output of a model? How do you pass context to it using techniques like RAG and, advanced prompting techniques like React or chain of thought? So you need a mix of background coming from distributed systems expertise, plus they should know a little bit of AI and ML as well. And honestly, we don't need like pure data scientists to do this, because most of the times we are not building models ourselves, at least on the AI app side. Whether we are fine tuning them, or we are trying to use our own data with those models. So that, I feel, is the right skill set. And I would rate the distributed system expertise even higher than AI ML expertise at this time. But if you have people who know how to build distributed systems and they could be trained on AI ML, I think that's the right mix, in my opinion. And then obviously product thinking, right? We all have to be critical thinkers. You can't be just engineers and get assigned tasks and somebody else is doing the product requirements and we are actually just building it. That has to change in the world of AI, right? Everybody needs to have that cross-functional mindset, think about the customer, think about scalability, think about security. So that's on the build side. And then on the testing side, again, like I mentioned, in this case, we are not validating exact outputs. We are validating what I would say behavioral quality over time, right? So which means like we have to define the evaluation metrics on, how should I measure the output of an AI system, whether it's automated decision or something that the output is generating, the AI is generating. How do we have human evaluation loops in there? And then how do I continuously monitor the output of these systems? So, I look for things like drift and whether the output is degrading. So how do I build all of that? I think those are the skills that are needed to build AI systems.
Absolutely. 100% love everything you said. And I guess to kind of go back to something you alluded to, and I just maybe want to dive into more. When we are building these AI systems, I guess traditionally we have spent enough time on user experience and other forms of technologies for quite a long time. We now know the web, mobile, we know all these different facets. When we're looking at AI, that is something that is definitely new. And I think maybe the thing that I am not sure about and think that maybe you to call out here is a lot of consumers, when their first interaction with AI has been, typical what we've seen with a lot of these GPTs, a question, prompt answer, sequential. It's setting some baseline expectations, I feel, which is not always going to be easy for enterprises to deliver. When you're looking at user experience for AI systems from interacting with it, is that helping or hurting that the end user is so exposed, if they want to be, to how AI is being looked at, from Gemini to Claude to ChatGPT? They all have the same interface. It's pretty standard at this point.
That's a great question, right? And, I would say, having end users exposed to tools like ChatGPT definitely presents a lot of challenges, right? Because now every enterprise is trying to catch up to ChatGPT, right? And specifically from a user experience perspective, I think we touched upon that a little bit, right? So when we are building AI systems, and by the way, I'm not only talking about chatbots, right? I'm talking about just in general AI systems. Chatbot is just one specific type of AI system, but we talked about testing the output, right? So how do you validate the exact output? But at the same time, when we are building traditional apps, right, we assume sub-second responses, let's say, for example, right? So as soon as I click a button on a website, I should immediately get like a response, and it should just happen for millions of users at the same time, right? Now, with AI, and especially if we are using reasoning models, sometimes it could take seconds or even longer for the response to come back. Now, you layer on top of that all the background processing that has to happen before we send our input, our prompt to the AI, and you are easily talking about seconds. So when we are designing UX, which is tailored for AI, we have to think about these aspects of the design and the limitations of large language models and the response times. So, we have to design the system. So maybe, one of the things that we learned from, chat GPT is like we can start streaming partial responses so users see progress, right, as it's flowing, as the content is getting generated. We can maybe do asynchronous background processing for heavy tasks to parallelize it, right? So we have to clearly think about these aspects of it. I guess I should say, like, AI UX has its own rhythm, right? That, all our product partners or product stakeholders as well as engineers need to understand that it's not going to be some milliseconds. It's not going to be 100% accurate. We have to have disclaimers. So things like that are very important. There should always be a human in the loop, right? When we are actually building these AI systems. So those are the kind of things that, we need to make sure that, not only our engineers, but our product partners, our UX, our business, as well as end users understand.
I think, you mentioned product. Traditional software development life cycle, I think everyone knows it. We don't need to, it's been around for 50 years of a version of it, a waterfall, Scrum, it doesn't matter. They all go through various similar activities at different stages. So we know that. When it comes to AI, and the tools are maturing at various levels. I call it democratization of technology because the end user can do potentially more. If you look at the relationship with product right now, it's a particular dynamic with the technology team, right? There's a lot more handed off because engineers need a certain threshold before they take over. As you're kind of looking at that relationship and going, hey, there's a lot of these tools that are able to mock up, do prototypes, they are able to build, that relationship is going to evolve. I guess, what are you seeing anything in that relationship? Is something changing the way you're working with those product teams?
Absolutely. And actually, I want it to change, right? So the traditional software development life cycle, right, where you have your product team defining requirements and then engineering team executing on those requirements, I don't think that's going to work. You can't requirement dock your way to AI success, right? So what needs to happen here is, and you're right, like with these vibe coding tools, even our product partners now can build prototypes quickly. And I think that's a great thing, right? Because with these vibe coding tools, you can quickly take an idea and see how it looks in action, and then maybe you can hand it over or work in collaboration with your engineers on how to scale this, right? So I guess where I'm going with this is, with AI you often can't define requirements fully in advance, right? Because there are no set templates, there are no proven roadmaps that you can copy from other industries or from other technologies. So engineers and product teams have to work hand in hand, and they both should be open to change. They have to co-create, and I believe the right approach is like build up MVP quickly, right? Launch it with a small set of maybe innovation friendly customers and iterate on feedback, right? So like I was talking about earlier, the product teams need to understand a little bit more of engineering and what are the limitations of AI. And on the same of our engineering teams, they need to understand a little bit more about product and our customers, and they need to have a product sense. And it won't be perfect, right? In my opinion, speed matters because the AI ecosystem is evolving so rapidly. So even if we incur some tech debt, it's acceptable to actually incur some tech debt early on. But speed is of the essence here. No matter how much time you spend in architecting a perfect system, that's not going to happen. Perfection doesn't matter right now. What really matters is perfection in terms of architecture is what I'm saying. What really matters is whether you're putting out a good quality product quickly and working collaboratively with your product team. So I think it's a mindset change both from a product as well as engineering perspective.
Yeah, I think it's interesting because so much is made of technology project failures, right? I think it's something, there's statistics out there. I won't quote them because maybe they've changed since the last time I read them, but it's a high failure rate. And I think it's difficult because we say they're IT project failures, but there's a couple of things in there that I think it's worth discussing when we talk about the evolution and maybe the software development lifecycle. Obviously, the gap between when you mention the problem is identified to when there's a solution takes time. The translation of communicated workflow, product, all those changes are very difficult to capture without a picture is 1,000 words. I actually am optimistic that we might see more with some of these vibe coding tools, some of these various ways that we can incorporate them within the life cycle, that we actually are going to see an improvement on the success rate of project delivery, because not as much is left for the engineering team to interpret. And not that engineering teams are bad, but second, third, fourth hand versions of information is hard. I am curious, do you share that optimism that we're going to see an improvement in that delivery, or do you think it's one of those where, we're going to introduce unknown complexities that we'll just have to deal with later?
No, I think I agree with you. Actually, if we have with the evolution of these vibe coding tools, it will definitely make the communication better between product and engineering teams, because, like you said, a picture is worth 1,000 words, right? A prototype is probably worth a million words, right? If you can see it in action and then you are asked to scale it, I think that will definitely be better. I think we just need to make sure that the expectations are set right on both sides, right? So the engineering teams, if they are looking at a prototype, they should not assume that this is exactly what they have to copy, right, in a production quality app, right? There is still room for negotiation. There is still room for, communication and discussion. At the same time, when a product team is building something using a vibe coding tool, they should not assume, hey, I can build this in 5 minutes. Why is it taking 2 weeks or 3 weeks for you to put this in production? Well, there are so many other things that we need to worry about, which you don't have to worry about when you are building about a prototype. Things that we talked about earlier in terms of security, scalability, reliability, and all those other things. So as long as we are working collaboratively and understand each other's perspective, I think this will definitely make the communication better between product and engineering teams, and it will lead to better products faster to the market.
Absolutely. I guess the natural extension to the conversation, we've been talking about advanced technologies. When you have to go back to your stakeholders with the executive team and you have to help identify the value, establish some type of ROI. I mean, these are maybe skills or technologies the team hasn't invested in before. There's a lot of unknowns, typically when it comes to budgets and stakeholders at the executive level. They don't like any of those unknown variables. I mean, it's not necessarily what they want to hear, but it might be a case where there isn't really an option, or maybe we have to use some of the past learnings from other similar areas. But what have you seen when you're dealing with AI solutions, investing in AI? What is it you've seen in terms of communicating with the executive team into those areas of, value, ROI, etc.?
Yeah, I think before we get to ROI, I think it's very important that we set the org structure right for this, right? So, and this not only applies to AI, but any evolving technology, right? Whether we talk about AR, VR, quantum, blockchain, right? These are uncharted territories, right? So, if we treat emerging and advanced tech just like a normal feature request, we'll kill the innovation before it starts, right? So I think the right approach is to probably from an org structure perspective, is to create innovation pods, right? Which are like small, cross-functional, autonomous teams that are outside of your standard, software development lifecycle. And this could be like engineers, product managers, UX designers, maybe customer support, maybe even marketing, right? Working together, and they having the freedom to fail fast and pivot quickly, right? And their charter should be to just build quick new prototypes and demonstrate them to leadership, and sometimes directly to customers and other stakeholders, and churn them out quickly. Maybe every 2 weeks you build prototypes, show them to your partners and your stakeholders and your leadership, and discard what doesn't resonate and double down on what does, right? So that's, if we have that kind of an innovation org structure, which is like separating R&D from actual productionization, then once a concept has traction, which has come out of this innovation pod, then we can hand it to specialized teams that can handle the productionization and security and scalability. And this innovation pod moves on to the next big thing, right? So, and you talked about measuring their success, right? So we can, there are a number of ways, we can measure metrics like how many prototypes have been built, right? What percentage has been tested with customers, what was the time to first prototype? What's the quality of customer feedback? So if we have that kind of an innovation cycle, is what I call it, right? Then we'll be able to come up with new ideas quickly and productionize them. I guess, just going to the leadership and telling them, hey, I need like $1 million for XYZ project without showing them any kind of value, it's very hard. It's a very hard sell, even though there is, everybody wants us, our board, everybody wants us to do AI, but we have to actually put our foot on the ground and see what's actually working, what's demanded in the market. And for that, this kind of an innovation structure helps, because once you have something that sticks, then you can build upon it. You can launch an MVP, you can launch a pilot, and then gather customer feedback. How is it getting adopted? And then scale on top of it.
Absolutely. I guess maybe last question, and you mentioned scaling, and I think there are lots of AI initiatives out there. I don't know how many have reached the bounds of cross-org solutions yet. I think we still might be early for some people. Some people are working on it. But when you think about some of the, I guess maybe the challenges, right? I think we can all assume some of the opportunities, but some of the challenges when you do want to scale cross-org with an AI solution, what are some things that you typically have to think about? What are some things that you're seeing that might limit the speed to getting to like a true cross-org AI solution?
Yeah, that's what we all struggle with, right? So the challenge is we want to avoid building AI features and products that are tightly coupled to one product, because if you do that, and assuming that product is only used by one org, then you have cornered yourself and you have isolated yourselves, because you have built it so customized, the product that you have built, AI product, so customized that you can't scale it to other orgs, right? So my philosophy is that instead what we should try to do is build like self-contained modular AI systems, right, that can be deployed in multiple contexts, right? So I think I should probably use an example, right, because I think the chatbot examples resonates with everybody. So if we talk about an AI chatbot, right, when we are thinking about building it, right, it should be a full package that can be deployed to, let's say, any website, right? Now, it should still be modular in the sense we should be able to customize the front end. We should be able to customize the back end orchestration logic, maybe the vector database that's powering the large language model and providing it context. It should have swappable data sets. And as long as we have all these modules working together as one coherent, self-contained unit, and it's pluggable, right? Which means I can actually plug and play it to any website. I would call it a success, right? That means I can build it once and customize it often, whether it's from a front-end perspective or the back-end database perspective. I can do faster deployment because it's plug and play. I can maintain the code base easily because, I can just update it in one place and it just gets available to everybody. And then I can also have more control over the security, the cost and, the tooling that comes with it. So I feel like building those self-contained modular AI systems are the key to success, instead of trying to build it for one product and working with one particular engineering team to integrate it with their systems, and having somebody else build the UI versus somebody else building the backend database, right? And then you just playing the middle role. So having that end-to-end vision in place for building these self-contained AI systems is I believe the success criteria, and I should is the mechanism to get to success for cross-org AI solutions.
That's fantastic, and definitely appreciate you coming on the show, sharing with us, Sumit. If somebody does want to reach out with a follow-up question, is there a good way of connecting with you?
Yeah. I am very active on LinkedIn. So you can reach out to me on LinkedIn as well. And, I can share my personal email, and you can reach out to me through email as well.
Awesome.
But I really enjoyed being on this podcast and having this conversation. I'm very passionate about this stuff. So, I love to share my experience and learn from others as well. I think some of the thoughts that you shared today, Amir, were very helpful and, changed my perspective a little bit as well.
Awesome, man. I appreciate it. Thank you for definitely coming on and sharing with us as well. And that's the end of this episode. We'll be back again, different guests, different topic. Until then, two things. One, I think Sumit did a great job of sharing his thoughts on really, moving to a productionized version of whatever AI solution or advanced technology you're dealing with. Obviously, we talked a little bit about some of the differences between older solutions versus AI, and we talked a little bit about the user experience, dealing with product teams, that relationship, value, and some of the challenges around scaling across the org. So please share this episode with somebody else. I thought Sumit offered some great insights. I'd appreciate that. Also, like, subscribe, comment. Let me know how the show's going for you. Until next time, thank you and goodbye.